Hello guys, in this video we are doing purification of copper. So want to see the electrolytic cell which is used on the purification of copper. So what we need to do here is to know what is this and what is that. So we have this one is the negative terminal, this is the positive terminal. Then we must have an electrolyte inside our cell. So when we purify copper, it's like we want to remove impurities, whereby we are transferring copper from one electrode to another. So one electrode must have impure copper, and the other one must have pure copper, where the copper ions will be deposited to form pure copper. So in this case, we have this one is the anode. Remember, we know that anode is connected to the positive terminal of the cell. So anode, which is the impure copper, or it is called blister copper in other ways. Blister copper. And this one is the cathode. It's called, here we will use copper, or we use pure copper. Then this is the cell. Then this is the electrolyte. So our electrolyte must be copper 2 sulfate in aqueous solution, so that our ions will be free to move from one electrode to another. So the process that happens here is at the anode, oxidation takes place. Well, let me say oxidation. Here there is oxidation because the type of reactions that will be taking place throughout this cell is a redox reaction. Yet we know redox reaction is it consists of oxidation and reduction. So in this case, oxidation takes place at the anode, which is impure copper. So we need to show the half equation for the oxidation of copper. Well, it's copper solid being being oxidized to form copper ions, and oxidation is the loss of electrons. So 2 electrons will be lost. So this is the half equation that is taking place at the anode. Then in the cathode, reduction takes place. Copper is being reduced there. Then the half equation for the reduction of copper is copper ions, which are already in the solution or in the electrolyte, and they are gaining 2 electrons. Then we form copper solid. So this is aqueous and solid. So this is how copper is reduced. Then the impurities from the blister copper, they fall here. Then they are collected at the base of the electrolytic cell. Impurities, examples of impurities can be zinc, silver, or gold, etc. Also platinum can be part of impurities. Then, but you find out why these impurities are not reacting, or why are they not oxidized in this reaction. Okay, this is very easy, because impurities, they have a low oxidation potential, meaning they cannot be easily oxidized compared to copper. If you check on the reactivity series, you find out copper is on top as well as these ones. So these ones, they are lower on the reactivity series, meaning the chances of them being oxidized in the presence of copper are very low. So as the reaction proceeds, let's check the observation that we'll be seeing as the process continues. You find out the anode reduces in mass. Why? Because the copper ions in anode are being transferred and deposited to the cathode, and the cathode gains or increases in mass. Why? Because it is gaining the copper ions which are being deposited there to form solid copper. So this is the process of the purification of copper. So